Hello, you've reached the final lesson of Unit 2. We're taking what we've done the last 2 days, and we're getting into Arithmetic Series today.
So Arithmetic Series is an indicated sum of terms of an arithmetic sequence. So basically we're adding another step to the arithmetic process.
We're going to take the sequence, we're going to lop it off at a certain point and say, all right, let's add all these terms together to find out how many we have there.
So then we would get subscript n equals n, which is the number of terms in the sequence, parentheses multiplied by t1, which is our first term, plus t subscript n, which is our last term, and divided by 2.
And that t sub n, that last term, whichever term it is, will vary depending on the problem.
Now, before you freak out, looking at this is just a simple Greek sign in the middle that just basically stands for sigma. So we're looking at the number, which is the stop. And then we've got the explicit formula, and then we have k equaling the number of our start. So basically you're going to have a start number and a stop number, and then put it into the explicit formula.
And so your start number will almost always be 1. I don't think I have any problems for you at this point that don't start at 1. And the stop is your n. So if you want to make a note that your stop is going to be your n, because you will be then using this formula once you use your explicit formula to get that information. So let's try some examples. Started off easy with A. We have first 6 terms in this arithmetic sequence, 1, 2, 3, 4, 5, 6. What is the sum? Yes, absolutely. If you want to go 1 plus 2 plus 3 plus 4 plus 5 plus 6, which 1 plus 2 is 3, 3 plus 3 is 6, plus 4 is 10, plus 5 is 15, plus 6 is 21. Absolutely. Well, what happens if, like, for instance, in example B, we go to the 25th term? I don't know about you, but I don't want to write out all 25 terms and then add them up, because somewhere along the way, with how much math that is, you're bound to make a mistake somewhere. So instead, I want to try using, I see here that I have 1, 2, 3, 4, 5, 6 terms. So that means that n is 6. I know that term 1 is 1, and term 6, or term n, is 6. So that means that to find the sum of the first 6 terms, I'm going to take 6 for n, times 1 plus 6, and I'm going to divide that by 2. 1 plus 6 is 7, so 6 times 7 divided by 2. 6 times 7 is 42. 42 divided by 2 is 21. So whichever route you want to go, if you can't remember that formula, which we will give to you, and you say, I don't remember it, I'm just going to add them up, go for it. But it might take you a while to do it. So now, we look here and we're given that we have 3 plus 12 plus 21 plus 30 plus dot 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 plus term 25. We're going to find the sum of the first 25 terms. I only give you 4. If you want to find the other 21 terms, have at it, be my guest. So what I'm going to do instead is I'm going to identify the pieces of the series in the formula. So I know that I need to know n, term 1, and term n. Well, I don't know term n. I know term 1 is 3, and I know n is 25. What I'm noticing here is that I don't know the last term, so I need to use the explicit formula to find it. So I need to find my explicit formula. Remember, that's term n equals term 1, which is 3, plus d. Well, I know that this is plus 9, plus 9, plus 9. So that's going to be 9 times n minus 1. Distribute that 9 and we get 3 plus 9n minus 9. Simplify that out, we get term n is equal to 9n minus 6. So now I can find term 25 by saying I got 9 times 25 minus 6. So if I take 9 times 25, that's 225. Minus 6 is 219. So now that I have that, now I know that this is 219. So now I can use my summation formula. So I take the sum of first 25 terms. So n is 25. Term 1 is 3. Term 2 is 219. And as you can expect, some of these numbers might get kind of large because you're adding together. And you divide by 2. Well, 219 plus 3 is 222. 222 times 25 is 5,550. We divide that by 2, and we get a sum of 2,775. So to sum that up, once we've identified the pieces, we substitute in the formula, and then we can add up the terms to check. I'm not going to save time in this video. The last piece for you today is when you're given the summation notation. So to do this, these ones I actually find to be easier, but that's just me. Find the number of terms in the series starting with k and stopping at the top value. So that means I need to know n, we still need to know term 1, and we still need to know term n, which n is right here, so n is 4, so that means I'm going to find term 1 and term 4. So what that means is I'm going to find term 1, I'm going to take this explicit formula and I'm going to put 1 in. So 6 minus 2 times 1. Well, 2 times 1 is 2, 6 minus 2 is 4. So term 1 is 4. Then I'm going to find term 4 because that's our stopping point. And we take 6 minus 2 times 4. Well, 2 times 4 is 8. 6 minus 8 is negative 2. So as you see, this one is a decreasing one. Now we've gotten those values. We're going to use the series formula now. So we've got S of the first 4 terms. We know that once again because of here. We've got 4 terms. Our first term is 4. Our last term is negative 2. We're going to divide that by 2. 4 plus negative 2 is 2. Now divide by 2. 4 times 2 is 8. 8 divided by 2 to get our answer of a sum of 4. And if we wanted to find term 1, 2, and 3 as well, we could do that. We're decreasing by 2, so it'd go 4, 2, 0, negative 2. 4 plus 2 is 6, plus 0 is 6, plus negative 2 is 4. So we know that it is correct. Now, get 2 simple problems for you. 1, find the sum of the first 18 terms. So yep, you'll have to find the explicit formula. It's good practice for you. And then go ahead and find the sum of the first 18 terms. And then use the summation notation where you're going from term 1 to term 8. Using that explicit formula, find your pieces and find the sum. And as always, bring your questions with you to class.